Okay, for 11a static and charges, what you need to know essentially at the start is static electricity by definition is electricity that cannot flow. So it will only happen on insulated materials. Like plastic is a very common place where you might find static electricity. And any other insulators obviously that have charges that are available to be built up in one charge, but they can't flow through the material. So a metal, for example, is a good conductor of electricity, so it wouldn't actually have a buildup of static electricity. Now, what you actually need to know is that static electricity, once you have that buildup of charge, which charges have been transferred from one place to another. So always in static electricity, the electrons do the moving. Okay, so if you have a plastic rod, for example, it's an insulated material, but it's a neutral material. So it has positives and negatives all the way, all around the material itself. But then if you scrape, let's say with a duster, you rub with a duster or you scrape the material, then what's going to happen is one of two things. Either the electrons from the rod are going to be transferred from the rod to the duster, so you'll rub the duster on the rod, the electrons may transfer from the rod to the duster. If that happens, then the duster has more negative than it had before, so the duster is negatively charged, and the plastic rod is therefore left with less electrons, so it's positively charged overall. Okay? This method of creating static charge by rubbing a duster on a material or by the application of that frictional force is called charging by friction. So one of two ways that you can create static charge on a material or object is charging by friction. So for example, if you're rubbing the object, you're applying friction between the duster and the insulating material, then you are going to create static charge on the two by friction. So in both those cases of negatives being transferred from the rod to the duster or vice versa, the electrons do the moving. The protons never transfer from one place to another. So in this case, if you transfer electrons away from the rod becomes positive. But if you'd have rubbed the duster on the rod and the electrons from the duster were transferred to the rod, then the rod becomes negative. Okay? Now, have two different types of rod. You've got polythene rods in this case, and you also have acetate rods as an example in the textbook. You don't necessarily need to know specifically, do the electrons move from acetate away and do they add to the polythene, but it does give you that example, so it's worth knowing. Alright, so in the first case, if you scrape a polythene rod with a duster, so you charge the rod by friction, then what happens is the electrons are transferred from the duster to the polythene rod. So this polythene rod is negatively charged. If I do that for two polythene rods, and I rub with charge by friction, I use my duster on polythene, then I'm actually adding electrons to the polythene. So electrons were transferred from the duster to the polythene rod. Two negative polythene rods then, we know that the same charges will repel. So negative, negative, put them close to each other, they're going to repel one another and they'll experience a force away from each other. If on the other hand you had an acetate rod, you charge the acetate rod by friction, you rub the duster on the acetate rod, what happens is the electrons are transferred from the acetate rod to the duster, leaving you with a positively charged acetate rod. So, in this example, the acetate rod becomes positive because electrons were removed from the rod. The polythene rod is negative because again, the electrons were transferred to the polythene rod, so it added electrons, therefore became negative. And of course, if you have two oppositely charged objects close enough to one another, then they will experience a force which is attractive. So that force will bring them together, and the force experienced will be along the field lines, which is something we'll look at in more detail in 11c. So that's the first way you can charge an object and create static charge, is if you charge by friction. Okay? The second way that you can charge in static electricity is called charging by induction. Now, slightly different. Best example to explain how you can charge an object by induction. If you take a balloon, an insulated material, it's rubber, you take the balloon and you rub it on your head. What you're doing whilst you're rubbing the balloon on your head is charging the balloon by friction. So the friction between your hair and the balloon. If the balloon becomes negatively charged, as it does in this diagram, that means that the electrons from my hair were transferred to the balloon, creating a negatively charged balloon by friction. Now if I take that balloon and I move it towards a wall, which is a very, very common example of how you can use static electricity, stick the balloon to the wall. If you take the negative balloon to the wall is neutral, okay? The wall is neutral in the first instance. Any other surface that you touch that you don't get a shock from is a neutral object, okay? If it hasn't been charged by friction or other ways. So if you take the negative balloon to a neutral wall, what's going to happen is the negatives in the balloon are going to actually repel the negatives that are in the neutral wall. Remember, a neutral wall is still made from positives and negatives. It just has equal amounts of both. So if I take the negative balloon and I put it close enough to the neutral wall, it will push the electrons back. That means that you're left with a surface of the wall which is positive. And if you have a negative balloon and the surface of the wall has become positive, they will attract. Okay, so look, take the negative balloon which you charge by friction on your hair, move it close to a neutral wall which has even positives and negatives, then the negatives will get pushed back because of repulsion and then leave you with a positive surface of the wall, causing the attraction between the balloon and the wall. So the balloon sticks to the wall. This is called charging by induction. The neutral wall wasn't charged by friction, it was charged because you put a charged object close to it and it pushed those negatives away, leaving the positive closer. So, if you'd taken a positive balloon, let's say you charged the balloon by friction and it lost electrons, it became positive, and you move that positive balloon close to the wall, then the same thing would happen, except this time the negatives in the wall would be dragged to the surface, giving a negative charge on the surface of the wall, leaving the protons further behind and causing that attraction again. Under no circumstances can charging by induction create a repulsive force. If you charge an object, the object is neutral. So you take a charged object that may have been charged by friction, close to a neutral object with no overall charge, then it will induce a charge in the object. Depending on the charged object, will it push the negatives back if the object is negative, or will it pull the negatives closer if the object is positive, and it will cause attraction. Every single time you charge by induction, it will always attract. Okay? And that's 11a, that's all you need to know.